Hello everyone. In this video I am going to take up MCQs which are based on gamma and exponential distribution, and for that first we will look into the important formulas and definition which are very useful. Gamma distribution is a continuous distribution and it is always a positive, which is defined on 0 to infinity. It is all positive skewed, and one important point is that it is the waiting time between the events, and it also predict the waiting time till further event occurs, or we can say it predicts the waiting time until the kth event occur. So first we will see that because it is a gamma distribution, so it is based on the gamma function, and this is a gamma function defined as, this notation is for the gamma, and this integral is a special integral known as a gamma function. And there are some properties of the gamma function. One is that if we want to open it, we can use this property when the alpha is not integer, so we can use this formula for the problem solving. But if n is integer, it can be rewritten in terms of factorial. And the last d part is also useful if some gamma value is asked which is not integer. That is remember, gamma half is root pi. Next is this slide is talking about standard gamma distribution, because gamma distribution we can write into two form. This left side I have written the first kind, which is also known as a standard gamma distribution. And how do we find out that whether it is a standard or not? For that, remember that there are two parameters for the gamma distribution of the second kind. It is beta and alpha. But when we take beta is equals to 1, it is defined as a gamma distribution of first kind, or we can say the standard gamma distribution. It is also denoted in this form, or sometimes some people can use this notation of gamma, and sometimes it can be written as this notation for the gamma. So both are same. And when the second distribution is there, which is of second kind, it always defines the scale. Here scale is 1, so it is standard. But when we have any value of the scale other than 1, we call it a second kind of gamma distribution. So it means we have a two parameter for the gamma distribution, alpha and beta. Alpha is defining the shape and beta is defining the scale. So we have to remember it. According to the question, it can be used. Now the next is one more case for the gamma distribution. It is a special case, and that case is converted into exponential distribution, and it is we can call it is a special case of the gamma distribution for alpha is equals to 1. So if we take alpha is equals to 1 in our previous second category of, or second kind of the gamma distribution, it become the exponential distribution, and we can write down, this is a PDF for the exponential distribution. Even some I have written 1 by beta, because some books can also write down as a theta e to the power minus x theta x, right? So one and the same thing, but in this discussion I am fixing the calculation work based on this 1 upon beta e to the power minus x by beta. So next important point which we want for the problem, it's MCQ purpose. This is a mean and variance for the gamma distribution. So mean is alpha into beta and variance is equals to alpha into beta square. So when mean is given, we will multiply alpha beta, and when variance is given, we will multiply alpha with the beta square. If we remember the mean and variance for gamma distribution, we can easily retrieve or calculate the gamma for the first kind, because when somebody say what is gamma for the first kind, it means alpha beta is equals to 1. So when beta is equals to 1 in the first, this equation I plug in, so I'll get both value as a alpha. So from here we can also identify that gamma first kind, mean and variance are same. So this is the only case where mean variance matching. And when we want to find out the mean variance for the exponential distribution, it is based on when alpha is equals to 1. So when alpha 1, mean become beta and variance become beta square. So we have to remember it, because a lot of MCQ question can be used or based on this result. Next is a moment generating function, and the moment generating function for gamma distribution is 1 upon 1 minus beta t to the power alpha. If I want to write down into the exponent form in the numerator, so alpha will be minus. So we have to remember that if this is written in this model, beta and alpha both has a coefficient minus. And the exponential is based on when alpha is equals to 1, so it will be reduced into this formula. And in case if somebody is looking for first kind, or we can say standard gamma moment generating function, then beta become 1, and it is or we can say 1 minus t to the power minus alpha. Now since there is a one important result, that the Poisson distribution with exponential, so what we need to remember is Poisson distribution is dealing with the number of event in a specific time interval, right? So we can call it a number of event might be 0, 1, 2, so it is a discrete by nature, and we can transfer, or it can be re-expressed into the exponential distribution, that within two events whatever time is to be weighted, so waiting time is defining a exponential distribution, so it become continuous. So we can sometimes in some questions, if Poisson distribution information is given, we can gather the information based on the exponential parameter. So we will see in some question how we can utilize it, and from here we can quickly have a one look that, for example, in the Poisson distribution, if the mean number of event per unit time is given, that means lambda is given, we use lambda for that. Then what we can do for the exponential distribution, we can calculate the beta value, which is an average time per event. So this can be calculated by taking reciprocal of the lambda, will give us a beta, right? So this become a very important result, can be used it. Now we can also observe some more important point here, because these are going to be a great help for the calculation work on the exponential distribution. This second number I have written, probability of x greater than x is equals to e to the power minus x by beta. That means exponential distribution is like this, and if you are looking for what is the probability that the time has exceed x, it means more than x is this part which is shaded. So usually what we can do integration from x to infinity, right? And we can write down our PDF here and integrate it. So instead of doing integration, if we want to do the MCQ question, we can quickly use this formula e to the power minus x by beta, and this formula is driven from this probability of x less than or equals to x, because if somebody is saying what is a probability less than x, less than x means it is a CDF, and here in the exponential distribution our value of x starts from 0, so it can be 0 onwards, 0 to x. So it means whether we write like that, in this case of exponential distribution, it is same as this value because the starting is 0 for that. So when we integrate it, that means here we have to integrate from 0 to x, the PDF. After integration, we get this answer. So what I want to convey via this slide, that now onward, if we are dealing with the question of an exponential, right, and we have to find probability of x greater than some point, we can immediately use this formula e to the power minus x by beta, and if it is less than the required point, we will use 1 minus e to the power minus x by beta. So in this way we can avoid integration and question can be done very quickly. This is one important property of exponential distribution, which is called a memoryless property. What does it mean? It means, for example, somebody said what is a probability of waiting time x more than m if we know that already n minutes has passed or elapsed. So what does it mean? It means to find a probability of this conditional under the exponential distribution is giving us the same answer if we find out the probability of x with the difference of m minus n. So when question will come, you can identify how this property can be used. So we will see that time. Now here, before the switching over to the MCQ, we have one more result, very important, and this relation is between normal distribution and gamma distribution. This relation says that if X is a normal distribution with mean, mu and sigma square, and if we take a standard normal variate which is X minus mu by sigma, if we square it and we observe that z square by 2 will follow a gamma distribution of a first kind with value of this alpha is equals to 1 by 2, and the limiting form of gamma distribution for when the this what we say shape is tending towards infinity, this x will the gamma distribution will behave like a normal standard normal distribution. So we can say standard gamma distribution will tend to standard normal distribution when your alpha will go to infinity. Now let's begin with the MCQs. Initial lighter MCQs are there. So let us take one by one. The first question is the value of gamma of 3 by 2. So we are observing that whenever this kind of question is given which is not integer, we are going to use this property which is saying gamma of n is n minus 1 times gamma of n minus 1. And in my current case, the gamma of 3 by 2 can be is equals to 3 by 2 minus 1, and here also gamma of 3 by 2 minus 1. So we are getting 3 by 2 minus 1 is 1 by 2, and inside also 1 by 2. Now we know that we have discussed in the beginning for this topic that gamma of half is root pi. So when we say root pi by 2, so we get a first option as a correct option for that. So there might be some questions people can ask for gamma of some fractional value 3 by 2, 5 by 2. So you can use this property and keep on opening till you get a gamma of half. Now second question has taken a gamma for the integral value. So we do not need to solve like this. What we can do here, the property can be used, gamma of n is equals to n minus 1 factorial. Because it is integer, so we can write down this is nothing but 4 factorial. And 4 factorial is equals to 4 into 3 into 2 into 1. So we know that this value is 12 into 2 is 24. So option B is coming out to be the correct option. Third question is MGF for the gamma distribution, and we have just seen it is a memory based problem, and we observe that we always have a 1 upon 1 minus beta t to the power alpha, and it can be written in this form. So D option is the correct form. So this was some memory based question. Now the fourth question is mean and variance of the gamma distribution is given. So recall mean is equals to alpha into beta and variance is equals to alpha beta square. So they gave us alpha into beta is equals to 24 and alpha beta square is equals to 192, and we have to look for the alpha and beta value. So what can be done? We can divide variance by mean and we get a beta value. This means 192 by 24. When we simplify, we are going to get 8. So beta is 8 here. So we see B and C option are talking about beta. Now we want to find out alpha, so we can put it into this expression. So alpha is equals to 24 by beta, which is equals to 8. So we will get that is coming out to be 3. So 3 and alpha 3 and beta 8. So option B is the correct answer for this question number 4. In question number 5, they have given a random variable x which is following gamma distribution. Now alpha and beta value is given and we have to find out mean and standard deviation. So we have to be very careful. Mean is equals to alpha into beta and standard deviation sigma is equals to square root of alpha beta square. So they are not asking variance, they are asking the standard deviation. So alpha into beta is 2 into 3, which is 6, and alpha beta square is 9 to the 18. So square root of 18 is coming out to be 4.2426. So option C is the right one. In question number 6, which of the following is the PDF of the gamma distribution for the first kind, or we can say standard gamma distribution, and we know that the standard gamma distribution is option A. So it is a memory based. You have to remember all the PDF. Second is second kind, and the third option is for the exponentials. But in current question they are asking for the first kind, so A become the correct option for this question. Now this is also a memory based exponential distribution, continuous random variable x with the parameter beta, which is, you know, that mean is equals to beta and variance is equals to beta square. So we are not looking for variance, we are looking for standard deviation. So beta square is beta. It means the standard deviation is also beta and mean is also beta. So B option is coming out to be the right option for that. So first value is beta and second also beta. Now in question number 8, they gave us a continuous random variable x with the probability density function and the mean. Now here they have not mentioned the kind of distribution. So we can identify whenever we see here, whenever the PDF is given something is here and we are observing the same thing is the coefficient of x, it means it is always a exponential. So we can identify exponential distribution can be easily identified, right? So it is an exponential distribution, and we know that here exponential distribution, this is we are using in the formula as a beta. So I'll fix into the same model. So it means my 1 upon beta value is given as a 2. So it means beta is equals to 1 by 2. So we can retrieve the parameter. So in exponential distribution there is only one parameter, which is beta, and the moment we got a beta, we got a mean is equals to beta square and variance is, sorry, not beta square, mean is equals to beta and variance is equals to beta square. So it means half and half square. So it is option B. Now let's see the next question. It is talking about exponential distribution. X is a random variable which is exponential distribution with mean. That means mean is denoted by beta for the exponential distribution, which is given as a 0.5. Now they are looking for what is the probability of x less than or equals to this number. So I want we should recall the formula that probability of x less than or equals to a I have shared with you. I want let's have one quick glance over the formula which I discussed with you, that remember these two formula, we have to remember it so that we should not do the calculation work or integration. So if you want to handle a MCQs without doing integration for the exponential distribution, so remember when it is less than, it is a CDF, and formula of CDF is 1 minus e to the power minus here, then you write down this number in the numerator divided by beta. So it is less than. So when it is less than we do like that, when it is greater than we only write this part, right? So in my current question, this is my A, right? And this is a beta value is 0.5. So what we are going to do is formula is 1 minus e to the power half, negative is a formula, and beta is also 0.5. I know half and 0.5 are the same thing, so we are getting half is also 0.5, so they will get cancelled. We only left with minus 1. So in this case C become the right option. Next is the suppose system contain a certain type of component whose lifetime is t years. The random variable t is modeled nicely by the exponential. So first of all, we got information in the question. It is an exponential distribution with mean time to failure is 5. That means here beta is given to us as a 5. Now the query of the question is the probability that a given component installed on a system is still working after 8 years. That means we are looking for what is the probability that it is still working. So we have a t for variable here. T is more than 8. Now recall the formula. I have told you when it is less than we write down 1 minus, and when probability of t is let's say we can use a formula in terms of x. When it is a greater than a, the formula is e to the power minus a upon beta, and when it is less than 1 minus, because they are opposite of each other and total probability is 1. So we can remember this formula: greater than only e and less than is 1 minus this question. So we will do it directly by writing e to the power minus, in place of a I have a 8 and in place of beta I have a 5. So my answer is e to the power minus, that will be 1.6. But since in this question answer is not given in the exponent, so when we will simplify it, we get the answer is coming out to be, for this particular question, that is 0. We use calculator for that, 0.201 something. So it is close to the D option. So I'm going to tick the option D, which is near to my required value. So in this manner we can do it. Otherwise, for example, in here also, because the 9th and 10th question I used the formula for the exponential. Let's say if you are not aware of it, then you have to again struggle with what? You have to integrate from 8 to infinity. Then you will find out the PDF. PDF is 1 by beta, which is 1 by 5 e to the power minus x by 5 dx. So first is you have to integrate it and then put the limit, and then you will turn up with this answer. So I think this formula become a great help for question of a exponential distribution. Now let's see the 11th one. The time spent on a computer follows a gamma distribution with mean. So it is a gamma and mean is given as a 20, which is equals to alpha into beta, and variance is equals to 80, which is alpha into beta square. Now I want you find this question value on yourself and share your answer in the chat box. I'll see whether you have done it correctly or not. So this question I want you try yourself, right? So everything is in front of you. You only have to simplify to get the value of alpha. 12th question also I want you to do, because it is similar to the one which I have used for the formula purpose. They are saying assume that duration in a minutes of a telephone conversation that follows an exponential distribution with PDF of this 1 by 5 e to the power minus x by 5. So from here we can get a beta value as a 5. The probability that the conversation will increase 5 minutes. So increase 5 minutes means they are looking for x more than 5. So I hope you remember the formula which I just discussed with you, that no need of doing integration, because it is you can do this is only in the exponential, not other one, not in the gamma. In exponential you should know how to find this value. So I want you try and figure out which is the right option. Now come to the next question, which is the 13th one. In this question they have given us gamma distribution and asking recall 1 minus beta t, the moment generating function. So we get that alpha value is 2 here and beta value is 3 here. And we know that variance is equals to what? Alpha beta square. So I want, you can see this question, we can write on 9 to the 18, because alpha is 2, beta is 3, 3 square is 9, so 2 into 9 is 18. So C option is turning up to be the right answer for that. The 14th question is just a memory based. They are saying the memoryless property is followed by which of the following continuous distribution, and we know that it is only followed by the exponential distribution. The next few questions I have taken up for the same property, so that you should know how we can implement it. So we can see this question, whenever somebody is giving you exponential distribution and they give you this kind of conditional probability, you can use a memoryless property over here. So remember, for that, if you know, if somebody is looking for what is the probability of x, just a minute, let me make it nicely. What is the probability that waiting time is more than m, when you know that already that n time is already elapsed? So it means instead of finding this conditional, you can find the probability of difference of this waiting time. Obviously n is a more, because you have already waited this much. You're looking for what is the chances that you have to wait more than n. So you can just see the gap of m and n, and question can be done. So it means if I apply this memoryless property, I have to find out that probability of condition is exactly same if I take 3 minus 1. And what is 3 minus 1? That means probability of x more than 2. So when I will see, I observe that this is an exponential distribution, and we have just discussed that greater than any number is opposite of the, or you can say complementary of the CDF, and this value is nothing but e to the power minus a, this is 2, divided by beta. Beta is equals to here 1, so I will write down beta, and my answer is e to the power minus 2. E to the power minus 2 is not given, 1 by e square is given, so C option is the right. Now let's say, for example, if you don't know the memoryless property, then what will be done? You have to use the formula of probability of A slash B, which is equals to probability of A intersection B upon probability of B. And you know that if X is time, it is a time, you are saying what is the probability of waiting time more than 3, when you know that you have already waited for more than 1. So the common value between them is probability of x more than 3, and this is divided by probability of x greater than 1, which is my B set. And we know that when we apply the formula, I can apply the same formula on the numerator. I can write on e to the power minus 3 by 1, which is beta, and denominator is the same formula, e to the power minus 1 by 1. And when we simplify, e to the power minus 3 upon e to the power minus 1 is equals to e to the power minus 3 plus 1, which is equals to e to the power minus 2. But what happened when we are doing it, a lot of work is to be done. But if you are aware of this property, memoryless property, you can very quickly calculate the answer in a 1-2 steps. So I hope you have gotten an idea. Here also the memoryless property based question I have created, but it is given in terms of the statement. Let us first read the question. It is saying, if average waiting time for queuing a bank is 10 minutes. So for example, that on an average 10 minutes is a waiting time in a queue. So it means beta is given to us as a 10. Now they are saying what is the probability that a customer will spend more than 15 minutes in the bank, given that they are still in the bank after 10 minutes. That means they are asking you what is the probability that they have to wait or spend more than 15 minutes when you are aware of that already 10 minutes they have waited. So what we need to do is we can find out the probability of x is, we are actually finding more than 15 minus 10, so that is more than 5. So here the answer is e to the power minus, remember the formula, probability of x greater than a is equals to e to the power minus a upon beta. So a is 5 and my beta is 10 here, so we are getting e to the power minus 1 by 2. E to the power minus 1 by 2, no fractional answer is given, so half value is 0.5, so option A is the right answer. That on Sunday morning, customer arrive at a cafeteria follow a Poisson distribution. Now relationship of Poisson distribution with exponential is going to be not exponential, I think it's, let's first read the question. On a Sunday morning, the customer arrive at a cafeteria follow a Poisson process with the average rate 15 customer per hour. That means 15 customer per hour. What is an average amount of time elapse before 3 customers arrive in the cafeteria? So first of all, we have to find out what is a waiting time for per customer. So it means I need a beta from here. So how do we calculate it? First, I want to convert the hour into minute because my question is in a minute. Okay, so what we will do, first we are going to convert into 15 per customer per hour, means one customer per 4 minutes. So one customer per 4 minute means I got my beta value, that beta is equals to 4 minutes. Now when beta is there, we can look for the question what is an average amount of time. They are looking for average amount of time elapsed before 3 customers. So now they are not talking about the 1 customer, they are talking about the 3 customers. So for the 3 customer, it means alpha is equals to 3 and beta is equals to 4 in the question. So they are asking us average amount of time, that means they are asking me the mean. So average value is mean, and it is equals to alpha into beta. So alpha into beta is 12 minutes. So we got option C correct. Sometimes the same question can be asked to find a PDF, so we will apply the same logic by looking into alpha beta, and we can find a PDF for that. Now let's see the question 18, which is again a concept based, a memory based problem. They gave two statements and asking us which is the right option. So first statement says the exponential distribution is a special case of gamma distribution. It is correct. Statement 2 says mean and variance are equal for the standard gamma distribution. We have also figured out both are equals to here because beta is 1, so both are equals to alpha. So both the statement are correct. So in this case option C is coming out to be the correct because both are correct. So sometimes some question can be based on the concept based, given in terms of some information in terms of a statement. You have to be very carefully pick the statement and identify what is the right answer. Fine. So 19th one is talking about the exponential distribution. This random variable with mean means beta is equals to 5. They are asking what is the probability of between 5 to 10. Now whenever the question is given in terms of the exponential, I will not prefer integration. For the MCQ purpose, we can immediately use the formula. It means from 5 to 10. So how do I calculate? I have to find out what is the probability of x which is less than 10. So from the 10, if we delete what is the probability of x less than or equals to 5, so my answer is we can use the CDF formula. So CDF of the formula, remember the probability of x less than or equals to a can be remembered as 1 minus e to the power minus a by beta. So here I can write down 1 minus, so beta is 5, right? 1 minus e to the power minus, my number is 10 divided by the beta, beta is 5 here. This is my first part. There is a difference with what? Less than 5. So less than 5 means 1 minus e to the power, my now a is 5 and beta is 5. So when I simplify, I get 1 minus e to the power minus 2. Difference from 1 minus e to the power minus 1. So 1 will get cancelled. This e to the power minus 1 become plus and e to the power minus 2 become negative. So we can see what is the right option. B option is the right. Otherwise what you need to do is the same process, or you have to integrate it, right? So if you want to get rid of integration work, especially in the case of exponential distribution, so why not to encash for the MCQs? Otherwise what you need to do is for this question you will write down 5 to 10. PDF value is what? Because here mean is beta is, so formula for PDF is 1 by beta e to the power minus x by beta dx. So you have to do integration and then plug in the value. So we can do that way. We are saying 20th question is if the continuous random variable x has an exponential distribution with PDF 1 by 5 e to the power minus x by 5, then the value of ex square. So first what we need to do is, because ex square comes in the formula for what? Variance, or you can say sigma square. Sigma square is equals to ex square minus ex whole square. That means you can get sigma square is equals to ex square minus mu square. So if we calculate mean and variance, we can calculate this value. So first of all, what is beta here? Beta is equals to 5. So I know that mean is equals to beta, which is equals to 5. Variance is equals to beta square, which is equals to 25. So what we can do, we can plug in over here 25. This is unknown, and 5 square is also 25. So we can always get ex square in case of this exponential distribution is always double of the variance. So we are getting 25 when 5 square become 25 will plus on the right hand side, left hand side. So it will be 50. So 50 is the answer, and it happens always like that because mu square and variance are always same for the exponential distribution. So when we transfer the every time it will become double of it. So we can get some kind of observation from here. Okay, so now I'm going to take up the last question, because here I want to do integration for the gamma distribution, because we have not discussed any problem so far wherein the integration is to be done for the gamma. So first let us look into the question. This question says, in a certain city, the daily consumption of water in millions of a liter follow approximately a gamma distribution with alpha as a 2 and beta as a 3. They are saying if the daily capacity of the city is 9 million liters of the water, what is the probability that on any given day the water supply is inadequate? Now we have to be very careful while reading this last line. Usually students make mistake in understanding of this expression. When the water supply inadequate means the consumption is increased from the usual one. It means when I want to decode this last line, it is looking for the consumption is more than 9. So more than 9 means we have to find out the PDF. Now here be careful, this is not the exponential distribution question. Don't apply that formula. Here we have to do integration. So recall the formula for a gamma distribution, which is equals to integration, because function, let us write down the PDF is x to the power alpha minus 1 e to the power minus x by beta upon alpha beta to the power alpha gamma of alpha, right? So we have to remember it. So when we plug in the value, what will be our PDF of this question? X to the power alpha minus 1 means 1, e to the power minus x by beta means 3, divided by beta to the power alpha means 3 square, and gamma of 2 is 1 factorial. So we can get the answer of here. Now when we want to do integration, we have to do the usual integration. So integration means 9 to infinity, because here x is always positive. So 9 to infinity, we will do integration of this PDF. So PDF is x e to the power minus x by 3 upon 3 square is 9, and gamma of 2 is 1. So we have to integrate it 1 by 9. So what I can do, I'm writing 9 outside, and I'm going to use the formula. It's a two function, so UV. I'll not use the integration model. I'll use the formula which is directly written. The answer is U integration minus U dash second integration, and so on. So here U is x and V is e to the power minus x. So my formula is U is as it is. Integration of V means e to the power minus x by 3 is going to be, integration value for that is minus 1 by 3 is coming out to be the denominator. Then there is a minus in the formula. Now we will differentiate x, which become 1, and then second integration is that whatever you have integrated here, once more when you integrate, you are getting minus 1 by 3 minus 1 by 3 become plus 1 by 9, and our integration is done. Now we can plug in the value of 9 to infinity. We can say that here the after simplification there is 9. I'm sorry, mistake. So when I multiply 9 inside, so I am getting, when we simplify it, now the upper limit is infinity, and remember e to the power minus infinity will tends to 0. So there is no contribution for the upper limit, minus of the lower limit. Lower limit is 9. So when I plug in x is equals to 9, this will be 3 times e to the power minus 9 by 3 is 3, and lower limit is e to the power minus 3. So when we simplify, this both minus minus become plus. So we got the answer is, it's becoming a little messy, but let me try to wind up this answer. So when I take minus 4 e to the power minus 3, and outside is also minus, so my answer is 4 e to the power minus 3. So for that my answer is coming out to be 4 times e to the power minus 3, which is option B. So in this manner we can solve. So when there is a gamma distribution, so better use this formula for U into V, for it's a great help. So I hope you have gotten some information regarding the problem solving for the exponential and gamma distribution. Thank you for watching.